The universe, with all its boundless complexity, has always been a source of fascination, wonder, and mystery for humanity. Over the centuries, our understanding of the cosmos has evolved dramatically, but there is still so much left to discover. With each new technological advancement, especially in space exploration, we uncover phenomena that not only defy our expectations but also challenge the very principles on which our scientific knowledge is built. One of the most astonishing recent discoveries, made by the James Webb Space Telescope, JWST, has left scientists and enthusiasts alike reeling in disbelief. A phenomenon that, until now, seemed so improbable that it shouldn't even exist has been uncovered. A series of rogue planets, detached from their stars and wandering freely through space, has been found in startling numbers in the Orion Nebula. Not only are these planets defying conventional understanding, but they are also accompanied by a bizarre twist. They travel in pairs, forming binary planetary systems, a finding that no one expected. The Orion Nebula, a bright and visually captivating cloud of gas and dust located in the constellation Orion, is one of the most well-known and studied regions of the sky. It's a star-forming factory where new stars are constantly being born. Over the years, scientists have studied the Orion Nebula as a natural laboratory to observe the various stages of stellar evolution. In many ways, the nebula serves as a window into the processes that give birth to stars and planets. It has long been a source of fascination, not just for scientists but for amateur astronomers, who can observe its brilliance with the naked eye. Yet, even with all this knowledge, what we thought we knew about the nebula and its inhabitants has been radically altered by the new findings from the JWST. The James Webb Space Telescope, launched in December 2021, is the most advanced space observatory humanity has ever created. With its infrared vision and unprecedented resolution, it is capable of peering deeper into space than any telescope before it. Its ability to observe distant galaxies, newborn stars, and exoplanets in astonishing detail has opened up a whole new era in our understanding of the universe. What makes JWST particularly remarkable is its ability to observe the cosmos in infrared wavelengths. This allows it to see through the gas and dust that often obscure our view of celestial objects. The telescope's instruments are so sensitive that they can detect objects that were previously invisible to other telescopes. As part of its mission, JWST turned its gaze toward the Orion Nebula. This region, rich in both gas and dust, is a perfect target for studying the birth and development of stars. But what the telescope uncovered in the heart of this star-forming region was far beyond anything scientists could have anticipated. While the nebula is known to contain many new stars and planetary systems, what JWST revealed were not just these familiar entities, but a startling number of rogue planets, planets that had detached themselves from their parent stars and were now roaming freely through space. At first glance, the discovery of these rogue planets might seem strange, but not entirely out of the ordinary. In the world of exoplanet research, rogue planets, also known as free-floating planets, have been theorized for some time. These planets are believed to have been ejected from their star systems due to gravitational interactions, collisions, or other dynamic processes. The idea of such planets has intrigued astronomers for years, and the possibility that such objects exist in large numbers was something that many had speculated but could not confirm. The theory was that, while rogue planets might exist, they would likely be rare. After all, the vast majority of planets are thought to be gravitationally bound to their stars, following predictable orbits. Rogue planets, on the other hand, were expected to be the exception rather than the rule. However, what JWST uncovered in the Orion Nebula has completely upended this assumption. Rather than being a rare phenomenon, rogue planets appear to be relatively common in this region. Even more astonishing is the fact that many of these rogue planets are not wandering through space alone. They are part of a strange and unique form of binary planetary systems, pairs of rogue planets that travel through the cosmos together, much like binary star systems, where two stars orbit a common center of mass. This discovery has left astronomers scratching their heads, as such a phenomenon was thought to be impossible. The idea of pairs of rogue planets traveling together without the gravitational anchor of a star is something that challenges our current understanding of planetary dynamics. To date, scientists have discovered over 40 of these rogue planetary pairs in the Orion Nebula, a number that is so large it suggests that there is something fundamentally different about this region of space. The discovery of these jumbos, as they have been named, short for Jupiter mass binary objects, has profound implications for our understanding of planet formation, star systems, and the dynamics of gravitational interactions in space. The fact that these rogue planets are in pairs and that they are found in such large numbers suggests that there may be an underlying cause or process that is responsible for this unusual phenomenon. But what is it? Is this something unique to the Orion Nebula, or could it be a common feature of other regions of space that we simply haven't observed yet? The key question that scientists are grappling with is how these rogue planets form in the first place. There are a few theories that could explain their existence. One possibility is that these planets were originally part of larger, multi-planet systems, where gravitational interactions between the planets caused some of them to be flung out of their orbits. This process, known as planet-planet scattering, occurs when planets in a system gravitationally interact with each other, potentially causing one of the planets to be ejected from the system. This could happen in a crowded star-forming region like the Orion Nebula, where gravitational interactions between multiple stars and planets are common. Another possible explanation is that these rogue planets were once part of a star system but were kicked out during a close flyby with another star. This process, known as stellar interaction, can occur when two stars pass close enough to each other that the gravitational pull of one star disrupts the orbit of a planet, sending it flying out of the system. Such interactions are not uncommon in densely populated star-forming regions, where stars are often born in clusters and interact with each other on a regular basis. A third theory is that these rogue planets could be the result of a gravitational instability in the early stages of planet formation. In some cases, a planet-forming disk of gas and dust around a young star can become unstable, leading to the formation of multiple planets that are not gravitationally bound to the star. These planets would then be free to wander through space, either alone or in pairs, as we are seeing in the case of the jumbos. While these theories offer some potential explanations, the discovery of the jumbos raises many more questions than answers. How is it possible for so many planets to be ejected from their star systems and then travel in pairs, maintaining a relatively stable relationship as they wander through the cosmos? Why are these planets so similar in mass and composition, resembling Jupiter-like gas giants rather than smaller rocky planets or icy worlds? And perhaps most puzzling of all, why are so many of these rogue planetary pairs concentrated in the Orion Nebula? Could this phenomenon be a result of some unknown force or process that is specific to this region of space? Or could it be a more universal feature of planet formation that we simply haven't recognized until now? The discovery of the jumbos has far-reaching implications for our understanding of the universe. It forces us to reconsider the validity of our previous assumptions about planetary dynamics, star formation, and the processes that govern the behavior of celestial objects. It also highlights the limitations of our current models of astrophysics, which, while incredibly successful in many respects, cannot fully explain the diversity and complexity of the universe we are beginning to uncover. The jumbos are just the latest in a long line of surprising discoveries made by the James Webb Space Telescope, which continues to push the boundaries of what we know about space. Since its launch in 2021, JWST has made a series of groundbreaking discoveries that have left scientists rethinking their understanding of the cosmos. From the discovery of surprisingly ancient galaxies to the revelation of supermassive black holes that challenge our theories of galaxy formation, JWST is unveiling a universe that is far stranger and more complex than we ever imagined. The telescope's ability to observe the earliest stages of galaxy formation, the birth of stars, and the intricate dynamics of exoplanetary systems is transforming our understanding of the universe on a fundamental level. The implications of these discoveries go beyond just the jumbos. The fact that JWST is uncovering objects and phenomena that don't fit neatly into our existing models of physics and cosmology suggests that our understanding of the universe is incomplete. In many ways, we are only just beginning to scratch the surface of what is out there. The jumbos, along with other unexpected findings from the telescope, are forcing scientists to reconsider the very foundations of astrophysics, from the laws of gravity to the processes that govern the formation of stars and planets. One of the most exciting aspects of these discoveries is that they open up new possibilities for the future of space exploration. As we continue to explore the universe with increasingly sophisticated instruments, we are bound to encounter even more unexpected phenomena that will challenge our understanding of the cosmos. The jumbos, and other similar discoveries, may one day provide us with the key to unlocking some of the greatest mysteries of the universe, from the nature of dark matter and dark energy to the origins of life itself. In conclusion, the discovery of rogue planetary pairs in the Orion Nebula by the James Webb Space Telescope is one of the most astonishing and perplexing revelations in the field of astronomy. It challenges our understanding of planetary dynamics, star formation, and the fundamental laws of physics. While much remains unknown about these mysterious jumbos, their existence suggests that we are on the cusp of a new era of space exploration, one that promises to reveal even more of the universe's secrets. As we continue to push the boundaries of our knowledge, the James Webb Space Telescope will undoubtedly be at the forefront of this journey, helping to shape our understanding of the cosmos for generations to come.